Hey guys, welcome back to the next video. In the previous one, we covered how amines react with carbonyls. And what we realized was that certain amines can create different kinds of compounds. So here's a quick summary of what we did before. Basically, we can react with three types of amines. Ammonia, which is NH3, number one. Number two is a primary amine. And number three is a secondary amine. And we react them with carbonyls. Now, if ammonia and a primary amine react with a carbonyl, they create these kinds of compounds called imines. Nitrogens are double bonded to the carbon. In a secondary amine, we did something differently. Because that amine only had one hydrogen, it resulted in this kind of a compound where the nitrogen was single bonded to a carbon, but that carbon was double bonded to another carbon, and that is called an enamine. All right, now in this video, we're going to be talking specifically about what imines and enamines, what we can do with them. So, starting with the imines. So let's say we formed an imine. Like this. Now, what we're going to do is we're going to use a specific reaction, and it's similar to something else you guys have actually already learned. Now, just like acetals are sort of similar to the mechanism we're doing here, acetals use an OH, here we're using nitrogen compounds, we're going to use something similar that you guys saw on double bonded oxygen compounds. When we have double bonded oxygen compounds, we were able to reduce them using LiAlH4 and NABH4. We're going to do the same thing here. We're going to perform a reduction reaction on imines and enamines. So, what is this specific reaction? It's going to be written out like this. Na parentheses CN BH3. All right, NaCN BH3. And in general, this reaction performs the best at pH 6. So on your exam, if you were going to be using this for, let's say, synthesis, it's a good idea to write something like this, pH 6. And just for completeness, how does this reaction work? It works similarly to how the other reduction mechanisms work. We use what's called a hydride. So let's say actually we start with, let's change this into a hydrogen. So this would have happened if we used ammonia as our amine. So we take our NaCnBH3, our sodium cyanoborohydride, that's what it's called, and we're going to use one of those H's on the BH3. So I'm going to write it out like this. I specifically wrote out one of those hydrogen bonds because that's what we're going to use, and what it does is that bond attacks that carbon of the double bonded carbon to the nitrogen. So it's going to attack there, and the H is taking those electrons. That's the key idea. The H is going to be taking those electrons from that bond, forming a new one to that carbon, and it's going to kick one of those double bonds up. Now that's going to give the nitrogen a negative if it takes on that lone pair. Nitrogens with negatives, we tend to try to avoid them, and pH 6 is an acidic environment. So what's going to happen is we have a bunch of H plus floating around. That H plus is going to be used by one of the nitrogen lone pairs, and it's going to take on that extra hydrogen. Now, if you want, you can even combine these two arrows like this. But to keep it simple, so you see this step by step, I'm just going to leave it like that. Okay, So what is that going to actually look like? So we have this compound, which that carbon of the double that used to have the double bonded N now has a brand new H. That nitrogen is now single bonded to that carbon, and it's got two hydrogens now. So for simplicity, I'll just write it like this. And you don't absolutely have to write out this hydrogen. This is more for you. And so you can actually even get rid of this. And what we have is another amine. In this case, a primary amine. And one common thing you'll see is once we do this reaction, reducing an imine, this idea is called reductive amination. We used an ammonia to form this imine. Then we reduced it back into a primary amine, and we can react it with another carbonyl, which we can then reduce again afterwards. And so we can keep doing this cycle and keep on reacting. And notice every time you use a certain amine, once you do the reduction step, you're going to get the next type of amine. So if you used ammonia, you'd get the amine when you do the reaction. You get a primary amine. React that with a carbonyl, reduce again, secondary amine, and so on and so forth. Okay, very similar reactions, and they're going to repeat itself. Ammonia and a primary amine, the mechanism is exactly the same because they both act on imines. There's nothing really different there. The only other difference is what happens with a secondary amine. Secondary amines create enamines. So typically what we're going to do is we actually keep this and we write it like this instead. So let's say I use a secondary amine, such as this one, and we react it with carbonyl. You're going to see NaCnBH3, pH6, all written together. All right. The reason we can even do that, this NaCnBH3, even though it's a reducing agent like LiAOH4, NaBH4, it only works on these imines and enamines. It's too weak to even work on the carbonyl. So we can have this all together, and that's how you're going to typically see it being written out. What happens is this is going to react first. That part won't happen any differently. Your secondary amine reacts with our carbonyl, and what do we get? An enamine. Now what happens is, if you remember at one point, your secondary amine is going to have a charged intermediate. If we go back to here, we look at the mechanism of our secondary amine. It starts off the same way as all of them. We attack our carbonyl. The O minus takes its one hydrogen. It gets protonated again. And that nitrogen then forms a double bond. They kick it out. And we get this called the iminium ion. That is what our NaCnBH3 reacts with when it comes to secondary amines. So you'll have this at one point. And before it even forms your enamine is when we're going to do the reaction. I'll write out the mechanism here, and then I'll show you guys the little shortcut steps. Oh. Write this. This attacks, double bond comes up, and that's already enough to neutralize it. It's not going to take an extra H. And so we're right here. And here's our H. And now I created a nitrogen with those two R groups connected to another carbon. tertiary amine. So when it comes to secondary amines, the NaCN-BH3 really reacts with that iminium ion. It doesn't really let the reaction go all the way to the enamine. If we didn't have our NaCN-BH3, we'd go straight to the enamine. But since we can have this together in the same sort of beaker / container, the reaction is going to go all the way to our iminium ion, and then it's going to get reduced into our tertiary amine. So let's add on to our summary, and sort of the shortcut of how to do these reactions is once you have your imine, in the case of an ammonia or a primary amine, or you have your iminium ion, all you do is, in the case of the imine, say it's this one, all you do is erase the double bond of the N when you redraw this, and give it an extra H. And that's it. That H that we added from BH3 is on that carbon, but we don't need to draw it out. When it comes to a secondary amine, we go do the same thing. We stop at our iminium ion. So here, and it's even easier. Once we write out our NaCN, BH3, pH6, we rewrite this exact thing, but we just erase the double bond and take away the plus, and that's it. We're done. So let's add on to our little summary table at the top so that you guys have a little chart for yourselves of how this works. So in summary, we can react primary amines and ammonia with a carbonyl, and we get imines. With secondary amines, we can react with our carbonyl, and we're going to get an enamine. Now, in the case of NaCN-BH3, we can react these imines and it's going to just erase that extra double bond, and it's going to add an H to each of those nitrogens. This was number 1 if we used ammonia, and number 2 for a primary amine. In the case of a secondary amine, we're going to do the same reaction, but stop right at our iminium ion. And then we use our NaCN-BH3 at pH 6. And we just erase that double bond. So we stop at the iminium ion. And then we do this. And this process again is called reductive amination. We do a reduction, and we're able to now create, we have a new amine. Every time you do this step, you use an amine and react with a carbonyl, and then we reduce it using NaCN-BH3, we create a new amine of a higher degree. So ammonia goes to primary, primary goes to secondary, secondary goes to tertiary. Okay? And just like I said before, when it came to secondary amines, how we can put the carbonyl and this together, you can absolutely do that when it comes to primary amines and ammonia. I can write out something like this. And we can start with, let's say, NH3. NH3 and the carbonyl will react, and they'll keep going until you get the imine, and then they reduce. Or, just like in the case of a secondary amine, the reduction can happen right at the iminium ion because we already have a reducing agent. Doesn't matter which one you want to use. If you want to use the iminium ion, if you want to use the imine product itself, the answer would be the same. All right, and that's basically how carbonyls and amines react. We saw the formation of imines and enamines, depending on what amine we used, and we saw how to reduce the imine and enamines into amines again, which we can use to react with other carbonyl compounds. So I hope this video was helpful for you guys, and I will see you in the next one.